Hello. Sometimes in calculus you will be asked to actually differentiate when you're not given the function. You're just given tables or symbolic, like a graph, and you're still asked to find the derivative. And we can actually do that. So here we're given that f of 2 is equal to negative 4, f prime of 2 is 8, g of 2 is 3, g prime of 2 is negative 1, and f prime of 3 is negative 2. And we're going to use that information to solve a, b, c, and d. So here, for part A, we're given f of x times g of x. In order to find that derivative, we know, since this is multiplication, we're going to use the product rule. So our derivative is going to be equal to f of x times g prime of x plus g of x times f prime of x. So far, so good. And I want to find this at x equals 2. Actually, for all of these, we're going to find these all at x equals 2. Well, to do that, we're going to look here. We're going to take it and plug in f of 2 is equal to negative 4 times g prime of 2 is negative 1 plus g of 2 is 3 times f prime of 2 is 8. So I can just multiply here. I've got 4 plus 24. So our derivative is equal to 28. I think these are kind of fun to do, actually. All right, so here we've got f of x to the third power. And if we want to find the derivative of that, we're going to use our chain rule. So this is going to be equal to 3 times f of x squared times, remember we've got to take the derivative inside, f prime of x. And we're finding this again at x equals 2. So this is going to be 3 times, well, f of 2 is equal to negative 4. We've got negative 4 squared times f prime of 2 is 8. So now we have 3 times 16 times 8, which is going to equal 384. All right, hopefully that makes sense. Let's look here at part C. We've got f of x over g of x. Well, that's going to be our quotient rule. So our derivative, and I'm going to write it here just because I have enough space there, is going to be the bottom, g of x, times the derivative of the top is f prime of x, minus the top, f of x, times the derivative of the bottom, g prime of x, all over g of x quantity squared. So g of 2 is 3 times f prime of 2 is 8 minus f of 2 is negative 4 times g prime of 2 is negative 1 all over g of 2, which is 3 squared. So I can kind of do some math here. 3 times 8 is 24. Negative 4 times the negative 1 is a positive 4, but this is a minus a positive 4 over 9. So we've got 20/9. I'm not going to simplify that anymore. And then finally, we have f of g of x. Well, f of g of x means that we're going to find f prime of g of x times the derivative of what's inside there, g prime of x. Well, f prime of g of x, well, this is going to be f prime g of 2, right? So I'm going to write that down. F prime of g of 2 is equal to 3 times g prime of x, and I should put this g prime of 2. Now this, earlier you might have wondered, up here, why did we have f prime of 3 but not f of 3? It looks like we've got the answer there. F prime of 3 we now know is negative 2 times g prime of 2 is a negative 1. So our derivative is just a positive 2. I didn't see that when I wrote that down, but anyway, there it is there. Good? All right, so now actually we also might have to sometimes find our derivative just from a graph. So here we're given a graph. H of x, the graph h of x is equal to f of g of x. And it looks like our purple line here is f of x and the red line is g of x. So let's actually try to find some of our derivatives here. We're asked to find g prime of 2. Well, at g prime of 2, if I look here at 2, this is about the point at g of 2. And g prime of 2, it looks like I'm kind of going to have to just estimate here. If I drew a line here and I calculated my slope, it looks like I have the point, well, this is the point 25, right? And it looks like I have maybe the point 46 right here, right? So in order to find that slope, I'm going to take 6 minus 5 over 4 minus 2, which gives me 1/2. That's it. That's my slope. How about f prime of g of 2? Well, g of 2, what is g of 2? If I look at g of 2, that was 5, right? So this is going to be the same as f prime of 5. Well, now I look here at my slope, f prime of 5. This is a sharp corner here. So am I going to be able to differentiate that? Do I have a slope? No. It does not exist. Okay? And finally, let's look at this last one here. H prime of 2. Well, h prime of 2 is going to be equal to f of g of 2, right? I'm sorry, I should say this is equal to h of x, right? Or of 2. I'm going to pause this for a moment. Okay, back to our last example. So h prime of 2 is equal to, well, h of 2 is equal to f of g of 2. So, like these go together, I should say. And then h prime of 2 is going to be equal to f prime of g of x times g prime of x, right? So, in order to calculate this, we're going to have f prime of g of 2 times g prime of 2. Well, what are these values? G of 2, it looks like, if I go here, g of 2 is 5. So now I have f prime of 5 times, well, g prime of 2. If we already kind of found that, right? That was 1/2. We actually already found that. 1/2. And f prime of 5, well, if we go to f value 5 here, our f, because this is a sharp cusp, we actually don't have a value, so this is dne, and dne times 1/2 is just dne. So hopefully all of that makes sense, how to differentiate from tables or symbols. If you have a question, leave it in the comments of the video, and I will see you in class. Goodbye!